This is the first of two short recaps on algebraic fractions. Fx equals 1 minus 3 over x plus 2 plus 3 over x plus 2 squared. X is not equal to minus 2. They specify x is not equal to minus 2 because if it was, the denominators would be 0 and the function would run off to infinity. Show that fx is equal to x squared plus x plus 1 over x plus 2 squared. So this first part of the question is about putting these three terms on a common denominator, and that common denominator is x plus 2 squared. Now the first term 1, it can be considered 1 over 1, so we've multiplied the denominator by x plus 2 squared. We need to do the same to the numerator. 1 times x plus 2 squared is x plus 2 squared. Second term is minus 3 over x plus 2. We've multiplied that denominator by x plus 2, so we've got to do the same to the numerator. The third term is already on x plus 2 squared, so we can leave that as plus 3 over x plus 2 squared. Now we need to simplify. X plus 2 all squared is x squared, plus twice the product is plus 4x, plus the second one squared is plus 4. Minus 3 times x is minus 3x, minus 3 times plus 2 is minus 6, and finally we have the plus 3. So fx equals, we have an x squared, plus 4x minus 3x is plus x, plus 4 minus 6 is minus 2, and minus 2 plus 3 is plus 1. And that's what we were asked to show. Now the next two parts of this question are not really about algebraic fractions, but they demonstrate how an A-level question can be put together, linking other parts of the syllabus. So part B, show that x squared plus x plus 1 is greater than 0 for all values of x. We do this by completing the square. X squared plus x plus 1 is equal to x plus, and we want half the number of x's, so that's plus a half all squared, plus 1, and now we need to subtract the square of the plus a half, so that's minus a quarter. So that gives us x plus a half all squared plus 3/4. And we can say that that is greater than 0 because we've got two positive quantities. The squared quantity is at least 0, and the second quantity is at least 3/4, and so added together they come to more than 0. Part C, show that fx is greater than 0 for all values of x except x is minus 2. So we can say that fx is equal to, now we've already got it in the form x squared plus x plus 1 over x plus 2 squared, but we can now say that that's equal to x plus a half all squared plus 3/4 divided by x plus 2 squared. Now provided x is not minus 2, we have a positive numerator and a positive denominator. So we can say both numerator and denominator are greater than 0 for x not equal to minus 2. Therefore fx is positive. It's greater than 0. A positive divided by a positive gives you a positive. Therefore fx is greater than 0 for all x except x is equal to minus 2. And that completes the recap.